Okay, chapter 13, the last chapter in this course, solutions. I think we all know that if we were stranded in the ocean, you should not drink ocean water, seawater, right? For one thing, it doesn't taste good. It's nasty. But the real reason is that why do you drink water? You drink water because you're thirsty, you're getting dehydrated. If you drink seawater, it will cause you to be more dehydrated than if you drank nothing. And one of the things we're going to learn about today is how does that happen? How does seawater dehydrate you more? Sometimes seawater is called a thirsty solution because it draws water to itself, like a thirsty person would drink water. So seawater is a solution, and a solution is a homogeneous mixture of two or more substances. In seawater, water is the solvent, and the solvent is usually the major component, the part of the solution that there's more of. Sodium chloride is the primary solute in seawater. The solute is the thing that's dissolved in the solvent, and that's the substance that's there in lesser amount. Nature has a tendency towards spontaneous mixing. The only exception is if that is highly unfavorable energetically. And there are definitely cases where that's true. So if we imagine this, we've got a container with water, and there's a barrier here. Could be like an aquarium with a glass wall in the middle here. We've got fresh water, pure water on one side, and salt water on the other side. Because there's a barrier here, they're going to stay separate. If you remove the barrier, even if you don't mix it at all, and you pull it out very, very carefully, the salt water and the fresh water are going to mix. It's going to happen spontaneously. This is nature's tendency towards spontaneous mixing. Any questions?
So how about like in the oceans where there's like two different parts and then like you can see the difference between each one?
You mean like where a fresh water comes into the ocean? So that's a good question. What about that? What you see is the fresh water is coming in, and as it meets the ocean water, mixing occurs. Because the fresh water is continually coming in, the mixing is always an ongoing process. And that's why you see a difference there. If the fresh water stopped, then it would all mix and become the same. Any other questions? So what happens if you drink seawater is that nature's tendency towards mixing causes solvent, water, to flow out of your body and into the seawater. So here we have part of your intestinal tract, and we've got, this is the inside of your intestine, which is technically the outside of your body. That's kind of weird to think about. And here's your cell tissue. There are sodium and chloride ions in the fluid in your cells. But the seawater coming in has more sodium and chloride ions in it. And nature's tendency towards mixing causes water from your tissues to flow through this semi-permeable membrane that allows water and specific substances to pass through it. The water goes out to dilute, to mix with the salt water. Yes?
Solid stuff? So it's about all the H2O?
Yeah, so it basically is drawing water out of your body. It's dehydrating you further. Did anybody brine their turkey for Thanksgiving?
What's that?
What is that? That's where you soak your turkey in salt water before you cook it. So what that does is this same process. It draws water out of the turkey. I'm not exactly sure why they do that, but I do know, like if you're making French fries or if you're frying certain types of vegetables that have a high water content, if you soak them in salt water to pull some of that water out, then when you fry them, they're crispier. Yep.
How do you brine the turkey to give it more flavor?
Well, it would give it more flavor, yeah. I don't know. I just started talking about this and I'm realizing, I should have looked into that. But, I say what comes into my head at the time. So, So, have you guys ever had teriyaki hot dogs?
No.
Did you even know it was a thing?
No.
They were actually really good. It's a cheap meal. So you make some teriyaki sauce because it's too expensive to buy it. And you take the hot dogs and you just slice through the skin just a little bit, kind of in a spiral fashion, and you boil the hot dogs in teriyaki sauce. Just till they're heated through. And then you eat it with rice. And it's like really good and cheap. Well, I made this once when we were newlyweds. No, not in a hot dog bun.
So you just make the hot dog over rice?
Yeah.
Okay.
Yeah, it's yummy. My husband we were both in graduate school, and so he was working late, and so I kept his portion hot in the teriyaki sauce. Wasn't thinking. Teriyaki sauce has a high sugar content and very high salt content, and so by the time he got home, those hot dogs were hard as rocks because it had sucked all the moisture out of them, all the water out of the hot dogs. So yeah, osmosis in action. I digress significantly. So that's what happens. So this tendency towards mixing. The salt isn't mixing because it can't go through this barrier, but the water can flow back and forth, and so it's going to go towards the more concentrated solution in an attempt to dilute it. I personify lots of inanimate things. So I think of it as nature's trying to make the concentration the same. And the only way it can do that is by moving water to the more concentrated side. And that dilutes that and makes the other side more concentrated. Any questions?
So how would the digestive system pull it out? The stuff they need? Why would they?
Okay, so how does your body get nutrients and things that it needs out of the food that you eat?
No, I'm saying why would you dilute it to extract something?
Well, this is what happens.
Okay.
So water flows from the less concentrated side to the more concentrated side. Me saying it wants to dilute it is my way of remembering and understanding what happens. Of course, it doesn't have a will, so it can't want to do anything.
No, I'm thinking of that.
Yeah, if you want to know about anatomy and stuff, then talk to the biology people. Yeah.